So again, what we want to do is we want to take this expression, this set of computing instructions, and see if through a logical sequence of steps we can reduce it down to another set of computing instructions that is more compact and more efficient. And we're going to do that by factoring and then canceling any common factors that might appear. Let's start by factoring out, looks like there's an x in each one of these in the top and an x in each one of these in the bottom, but not a 3, not any other numbers. So let's take that x out. So we'll start here with x, and we'll be left with 3x squared plus 19x plus 28 over, take an x out of the denominator, and we'll be left with 3x squared minus 2x minus 21. And now we can see that these x's are going to cancel here. Let's do that at the last step. For now, I'm just going to carry them along and then do all the canceling at one step. So let's see if we can factor this and this. So we're going to get x, see if we can get it to right here, x and, well, how about 3x and x? And now I'm looking for the factors of 28 that when I put here and multiply by 3, I'm going to get that 19. All right, so after some experimentation, what I'm going to use here is 7 and 4, right? That'll give me the 28. And I'm going to put the 7 here and the 4 here because that'll give me a 12 and a 7. I can get a 19 out of that. And since the 28 is positive, both the 7 and the 4 will have that middle plus sign. So we'll put a plus here and a plus here. Now in the denominator, bring that x down, and we'll go with a 3x and an x again. And now, again, what we're looking for is this negative 21. Oh, what a mess. We're looking for that 21, so how about a 7 and a 3? And a 7 and a 3, well, that gives me the idea to put the 7 right here, right? Because I think they're going to cancel. So let's go with a 7 and a 3. 21's negative, so they have opposite signs. And just because this is a plus, I'm going to put it right there. I'm going to put that plus sign there, negative here. Now let's just check it to be sure. Negative 9 plus 7 is negative 2. That factored form works. And now we can see that we have the 3x plus 7 is in common. The x is in common, so let's cancel those. All those will cancel right here, and then we're left with this much more compact, much more efficient set of instructions. How about x plus 4 over x minus 3? And we can do this as long as x is not equal to, now just come up right to the next step, right to the previous step. What's going to make this thing here equal to 0? Well, how about 0, negative 7 over 3, and positive 3. So we'll get 0, right? The 0 is coming from there. And then from here, we'll get negative 7 over 3, and from this one, we'll get the 3. Now, we haven't done these for a while, these cubics, so we have a pattern for it, right? We have 2 terms and 3 terms, so let's write that. We'll write our template. We've got 2 terms, 3 terms, and the 2 terms go like this. I'm going to call it uncube, right? We're going to uncube. What do you cube to get x cubed? X, what do you cube to get 8? Is 2, and we're going to use that middle plus sign. So we're going to write an x plus a 2. And then, once we have the 2 terms, we can get the 3 terms by running through a little pattern again. And here's the pattern. Square the first. So square the first, we'll get x squared. Now, multiply these two together and change the sign. So x times 2 is 2x. Change the sign, we'll get minus 2x. And then lastly, square the last. 2 squared is 4, so we'll get plus 4 all over. And look at that denominator. X squared minus 2x plus 4. It just happens to match that term, that factor in the numerator. So let's cancel those. That one cancels with that one. And this original set of computing instructions can now be written more compactly and more efficiently as this little one right here, just x plus 2. (15) Let's factor it. We've got difference of 2 squares in the top. So in the top, we're going to get those conjugates, x plus 5, x minus 5, all over the x minus 5 in the denominator. And what do you know? The x minus 5s are going to cancel. And then we're left with just this x plus 5. So we're going to write this now as x plus 5. And we can do this as long as x is not equal to, now just bring it right up to the next step. What's going to make that denominator 0? 5. So as long as x is not equal to 5, we're good to go.